Good day, grade 8 learners, and also the teachers that have accompanied their learners. My name is Tisetso Mohutle. I'm going to present a lesson on the particle model of matter for grade 8. Okay, the outline of the lesson is as follows. I'll first give a definition of matter, and then explain how diffusion occurs, then discuss the particle model of matter, then discuss the 3 primary states of matter, identify examples of each state of matter in everyday life. Then I'll end up the lesson by giving a summary of key points from the lesson. Okay, learners, let us start with the defining of the term matter. Matter is defined as anything that occupies space and has mass. You can think of anything that you can find in space. It can either be something that you can touch or something that you can feel, maybe touching your surface like air. Everything is matter. It must occupy space and it must have mass. Secondly, it includes all substances that we encounter in our daily lives, such as solids, liquids, gases, and even plasma. So everything that is in liquid form, in solid form, and gaseous form, they all constitute matter because they occupy space. Matter is made up or composed of tiny particles called atoms, which combine to form molecules. Unfortunately, they are so tiny, we can't even see them with our naked eye. Then there's a term called diffusion. Remember, matter is made up of tiny particles. And as I will describe the particle model of matter, you will learn that there are spaces between the particles of matter, which are the atoms. So diffusion means such particles will start moving past each other in a substance. So we define diffusion as the movement of particles of one substance with a high concentration to fill the spaces between a substance with lower concentration due to random motion of particles. This is similar to something like mixing milk with water. The particles of milk will go in between the particles of water. Diffusion is slower in liquids, but it is faster in gases. What does that mean? That means if you were to mix 2 liquids, they will mix much slower than if you were to mix gases. Gases would mix very fast. Now let us go into detail about the particle model of matter. The first important aspect about this model, it says matter is made up of discrete indivisible particles. These particles can be atoms, molecules, ions, depending on the substance. By being indivisible, it means we cannot divide those particles even further to make them smaller. That is the smallest that we can get. Number 2, these particles, as you will see with the arrows in between here, the arrows are indicating that there are spaces between the particles. The particles are indicated by round-shaped objects which are purple in color. So the arrows are indicating the spaces between those particles. So this is the second aspect about the model of matter. It says particles are separated by empty spaces. The volume occupied by the particles is smaller compared to the volume of the entire substance. If you were to measure the volume between all the particles, we would find that the volume, the spaces are much bigger than the particles themselves. The next one, particles are in constant motion. It means they are not stationary. They vibrate, rotate. Rotate means they turn around, they move randomly. They don't have a specific way they can go to left, right, up, or down within the substance. Now, the movement of these particles will always increase when you increase the temperature of a substance, and the movement will also decrease when you decrease the temperature of the substance. The other thing is that particles of matter, they can move anyhow, but they cannot move very further away from each other. The reason being, there are forces that attract other particles so that they cannot move away from the matter and get lost into the eternal space. So particles interact with each other through forces, and these interactions determine the behavior of matter. Lastly, matter with large spaces between particles can be easily compressed. What does that mean? It means the more the space between the particles, it means we can actually bring the particles much closer to one another because we can compress the space, make the space smaller. So diffusion occurs easier in matter that have large spaces. Please remember that. Diffusion occurs easier in matter that have large spaces. I have already given an indication that if you mix two gases, they will mix two different gases, they will mix much easier than if you were to mix two different liquids. Now let us look in detail about these three primary states of matter. The particle model explains different states of matter based on the arrangement and motion of particles. Now, the states of matter are solids, liquids, and gases. For you learners, you should know the ones that are shaded in red or written in red text. There's also another state of matter called plasma. I'm just mentioning it for enrichment. Now, the word states of matter, sometimes it is also named or called phases of matter. So you can use the two interchangeably. So for our syllabus here or our content in grade 8, we are only going to focus on solids, liquids, and gases. Now we'll start with the solid phase. Now these are the most important facts about solid phases. The particles in a solid are closely packed, as you'll see on the diagram here. The particles are represented by the round spheres here. So you can see there's hardly space between them. So the particles of solid are closely packed and they give a fixed arrangement. So they give it a particular shape. The particles have small spaces between them. That is very unique about solid phase. The next thing about solid phase, because the particles can be close to one another and give a definite arrangement, that allows for solids to have a definite shape. For example, if I were to take this cube and take it and put it into the beaker, do you realize that it will only occupy the space that it was occupying before it was put in the beaker? So it has a fixed space and it occupies a specific volume, which is the same space that it occupies. Volume is the space occupied by matter. The other points about solid phase is that because the particles are close to one another, they don't move easily away from one another. They can only vibrate around fixed positions, meaning they can just vibrate maybe side to side or up and down, but they don't really move away from one another. The particles attract each other with a strong force. Now, remember, the force is related to the space between particles. If the space between particles of matter is small, we say there is a strong force that is keeping them together so that they cannot move away from each other. The particles cannot be compressed. The reason? Because there's very little space. We cannot make this cube much smaller like it is. So it is difficult to make a solid particle much smaller by compressing it from side to side. You can only maybe change its shape, but you can not actually change the volume or the space that it occupies. And the particles cannot diffuse, meaning the particles of solid cannot go, if I put two solids in a container, the particles of one solid cannot move in between the particles of the another solid substance because the space is very small. Now, examples of such solid phase substances is ice, is one, a block of wood, or even a metal. Now, let's go to the liquid phase. What makes the liquid phase different from the solid phase is that the particles in a liquid are still closely packed, but loosely arranged. As you will see on this diagram, they are still packed together, but now we can see there are some spaces with the naked eye here. The particles have small spaces between them, but not as small as it was with the solid substances. Liquids have no definite shape. You can't keep a shape of a liquid substance. For example, if you pour 200 ml of a liquid into a volumetric flask like this, and then we transfer the same amount into a test tube, still the 200 ml, you see now the shape that this, it means you cannot have the shape of the liquid still be the same when you put it in a different container, because the liquid substance particles will move to occupy the container. So liquids they don't have a specific shape like it was with the solids. Now, particles in a liquid move past one another. We say liquid can flow, or liquids can diffuse. If particles can move past one another, we're saying there's a diffusion. The particles attract each other with a weaker force. Why is it a weaker force? Because the space is much bigger than it was with the solids, which had a stronger force. The particles cannot be compressed. Although there are spaces between particles of a liquid, they are not large enough to allow particles to squeeze in between those spaces. There are spaces, but they are not large enough to accommodate the size of the particles to squeeze in between. So we cannot make, for example, the 200 ml, we cannot make 200 milliliters of a liquid to become 150 milliliters. It is not possible. Though particles can still diffuse, but they cannot be compressed. Now, examples of the liquids. Water is a liquid phase, an example, milk or oil. Now we come to the last phase of the particle model of matter. Now the particles in a gas are much more spread apart. You see, now the spaces are much bigger now. The particles in a gas have very big spaces between them. Now, if I were to take this gas and pour it here, it will also occupy the shape of the container. If the container is very big, they will even spread even more. Right. The gases have no definite shape. They fill the entire space available to them. The gases have no definite volume. It means there's no specific amount of space that we say this gas can occupy. For example, I can put gas in a small container. If I transfer it into a bigger container, the particles of gas will spread apart to occupy the container. An example of what we already know in our daily lives, if you remember the gas can that we buy when we try to fill up the gas, it has got a compressed gas inside, which is being used maybe to make fire or something like that. So we can squeeze gas in a small container. We can also pour it in a bigger container. It will always fill the space available to them. The particles in a gas move freely. Why so? Because there is less force between them, force of attraction between the particles, and they move much quicker. The particles attract each other with the weakest force. So the force is the weakest in gases. Why so? Because we can see that the space is so far apart between the particles. The particles can be easily compressed. So you can compress any gas into a small container. Examples of the gases are oxygen, nitrogen, and carbon dioxide. Now, learners, it's very important now that we know this table, because I've spoken about the arrangement of the particles. How are they arranged in a solid? How they are arranged in the liquid? How they are arranged in gases? I also spoke about how fast the particles move, and we said they move much faster, the fastest in gases and the slowest in solids because of the forces that are stronger here and they are the weakest there. And we said the spaces, they are smallest here, they are the largest there, they are average there. The force is the most here, and then you become weaker and weaker. And then we'll talk about the behavior now. Now, this is a summary table. In relation to the arrangement of particles, it's a summary of what we've been talking about. It says particles are closely packed and in a fixed shape in the solids. What about in the liquids? Particles are still close together, but loosely arranged to allow even diffusion. Particles in a gas are not arranged in any specific way, and the diffusion can also still take place here. What about the motion? Particles here, they don't really move, they just vibrate. Particles move about their various fixed positions. And particles in a liquid, they move faster than in the solid and slide past each other. And particles in a gas, they move the fastest. What about the space? Particles have small spaces between them. In the case of liquids and solids, particles have small spaces that are larger than in solid, but then here in gases, particles have very big spaces between them. What about the forces? Forces of attraction between particles are very strong here. The liquids, forces of attraction between particles are weaker. In gases, forces of attraction between particles are the weakest. And then the behavior. it means the particles, because of the conditions above there, it means the behavior of solid, it means the particles cannot be compressed and there can be no diffusion. That's our conclusion. And then what about liquids? The particles cannot be compressed, but there can be diffusion. What about the gases? The particles can be easily compressed, and they can also have diffusion, which is much faster than in the liquids. Thank you very much, learners. That brings us to the end of the lesson. Thank you very much.